answer.
Okay. All right. For Unit 6, um, the topic is on haloalkanes or alkyl halides. Okay. So as the names goes, there is the word halo and also alkanes. So alkanes, like what you have learned in topic 3, okay, this is just uh, an aliphatic hydrocarbon like CH4, but now you are replacing one or maybe a few of the hydrogen with halo. This halo is actually halogen group. Okay, halogen, as what you have learned last semester, is from the periodic table, is group 17. Okay, so let's take a look on the outline. Okay, what you will learn basically is the naming of this alkyl halide based on their structure, or maybe you will try to draw their structure based on the names. Okay, so either way, so either as you are given a structure and give the name to it, or maybe you are given the name to draw the structures. And then we have this preparation of alkyl halide. How can they be prepared? Okay, one way is to prepare them using this free radical reaction or free radical halogenation, and another way is to prepare it using alcohol, from alcohol. And the last part, we will see some of the reactions that alkyl halide can have. For example, like nucleophilic substitution reaction. Okay, and then you have this, a few from this nucleophilic substitution reaction. Okay, it can form ether, nitrile, ester, amine, and so on. Okay, so we will see one by one each of these reaction later. So first, on to the introduction. So what is an alkyl halide? So basically, an alkyl halide or haloalkane is an alkane in which one or more hydrogen atom is replaced with a halogen. Okay, so imagine the simplest structures of methane. You have C and then 4 hydrogen, CH4. One of those hydrogen, when it is replaced with a halogen, okay, halogen can be any atom from group 17, but the most common will be uh, fluorine, chlorine, bromine, or iodine. Okay, fluorine, chlorine, bromine, or iodine. So when it is being replaced, the hydrogen being replaced with one of these halogen, then it will be known as a haloalkane. Okay, so haloalkanes are all immiscible with water. So what is the meaning of immiscible? Anybody knows what is the meaning of immiscible? What is immiscible? Have you heard of this word before? No answer.
Not turning into the homogeneous mixture.
Okay, correct. So that means if you mix haloalkane with water, it does not form homogeneous mixture. So probably they will have like separate layer or two distinct layer of the mixture. Okay, unlike later when we see alcohol, so alcohol normally can mix well with water. Okay, the boiling point, the BP, increase from fluoroalkanes to iodoalkanes. So fluoro, F is actually the first row. If you look at group 17, chlorine is at the first row of group 17, then followed by chlorine, bromine, or iodine. So actually it goes down the group, the boiling point will increase. Okay, and the smell is said to be generally how to say sweet smell. Okay, generally sweet smell, and the general formula. Okay, the general formula is Rx. What is R? R stands for alkyl group, or it can also be, if it is written as AR, then it is aryl. So you have learned in chapter 5 on arene, right? So if this written as R X, so this is if you have an aromatic group, okay, like benzene attached to one of these halogen. So R is actually alkyl, okay, ALKYL. So that means any group from alkane lah, okay. The simplest can be one carbon, like from methane it become methyl, then ethane become ethyl, okay, and so on according to the number of carbon. So this is the periodic table, okay, the periodic table. So group 17 is the second last group. So this everything in the group 17 is known as halogen. Okay, you have fluorine, chlorine, bromine, iodine, the first four, and then you have astatine and what is this? Uruseptum. Okay, but the first four is what is normally encountered in organic compound. So you have F, Cl, Br, and I. But when they become a substituents, okay, that means when it form bonds with an alkane group, you does not call it fluorine, chlorine, bromine, and iodine anymore. It will be known as fluoro, chloro, bromo, and iodo. Okay, we will see in the naming. Then, in terms of classification of alkyl halide, okay, so this is how they can be classified. We have uh, primary alkyl halide, secondary alkyl halide, tertiary alkyl halide, okay, and then do you have a quaternary alkyl halide? When it become
No.
quaternary, it is no longer known as an alkyl halide because there is no hydrogen anymore. Okay, that is not considered to be normally there is no quaternary lah. Okay, up until tertiary. So example of a primary alkyl halide is like the first example over here. We have methyl chloride. So what is primary alkyl halide? So if you look here, the general form of a primary alkyl halide is you have this R. So R is alkyl, and then you have this C, H2, and then X. So the terms primary stands for this carbon in the middle, the carbon that is directly bonded to the halogen is only connected to one other carbon. Okay, it is connected to one other carbon, which is this one. Okay, then for secondary alkyl halide, the CX bond, the carbon that is bonded to the halogen, okay, this one is bonded to two other alkyl group or two other carbons. So that is already the secondary. And then for tertiary alkyl halide, you have this CX over here. The CX, the carbon that is bonded to the halogen, is directly bonded to 1, 2, and 3 other alkyl group. Okay, so that's why it is known as primary, secondary, and tertiary. Example over here, we have this methyl chloride. So this methyl chloride, only one of the hydrogen is replaced with chlorine. So this CCl, is it a primary, secondary, tertiary? What is this? Is it a primary, secondary, or tertiary alkyl halide? This CCl. You look at the carbon that is bonded to the halogen. Is it bonded to any other carbon? No, right? So this is not considered to be primary, secondary or tertiary. So this is just known as methyl halide. So this is special case because the carbon over here is not exactly bonded to any other carbons. Then the uh, second one, uh, this one, oh, all of this is not primary, all of this is just methyl group. So none of this is an example of primary, secondary or tertiary. Okay, so but this one is bonded to one halogen. This is bonded to two halogen group, Cl, 2Cl over here, so 2Cl, and then you have three chlorine, and lastly all of the hydrogen is replaced. So the name will be different as well. When one of the hydrogen is being replaced with chlorine, it is known as methyl chloride, and when you have two chlorine, also sometimes known as methylene chloride, and three chlorine, chloroform, and the last one is carbon tetrachloride. But for uh, this is considered to be IUPAC. But these two, there are other IUPAC names for it. Okay, that means the naming, these two does not follow IUPAC naming. So let's see how actually can we name the alkyl halide. So first step, okay, as in alkene, okay, and what you have learned before, you must always find the longest chain and you will use it as the parent name, okay, as the parent. So look at this example, okay, uh, find the longest chain for this. So 1, 2, 3, 4, 5, 6, 7. So that is the longest chain. So if you still want to make sure, you try maybe from this 1, 2, 3, 4, 5, 6, 7. So it is the same. So you can start your number one either from this or from this because it will be still the same. Okay, and then maybe you want to try from this carbon. So 1, 2, 3, 4, 5. So that is only 5. So the longest chain will be 7. Okay, so that will be the parent. So if you have 7 carbon, okay, all without all single bond, no double bond. So 7 will be known as heptene. Okay, heptene. 7 heptene. So number the carbon of the parent beginning at the first substituent. Okay, regardless whether it is an alkyl group or halo group or halogen. So that means from this parent chain that you have, okay, the longest chain, you look at the substituents. So what is the substituents? You have this 1, 2, 3. So anything that is branching out from the parent chain, so that is known as substituents. So it can be alkyl, it can be halogen in this case. So but then again, so you number the carbon of the parent beginning at the first substituent. So we will try to give the lowest possible number. So that means you start from here. 1, 2, 3, 4, 5, 6, 7. Okay. This will be number 2, this will be number 4, and the bromine will be number 5. Okay. Maybe some of you ask, why don't start from here? So if you start from here, this end, it will be 1, 2, 3, 4, 5, 6, 7. The numbering will be 3, 4, and then 6. So that number is actually bigger than 2, 4, 5. Okay, so we don't want that. So always try to give the lowest possible number to the substituents. Okay, to the substituents. Then if more than one of the same kind of halogen is present, okay, if you look at this, there are two chlorines. Okay, there are two chlorines. So you have to number each and use one of the prefixes di, tri, tetra, and so on. So di stands for 2, tri is 3, tetra is 4, 5 is penta, and then so on lah. 6 will be hexa, 7 will be hepta. So if something like this, so the numbering will be 1, 2, 3, 4, 5, 6. Okay, so this chlorine will be at number 2 and 3 respectively. Okay, you don't start numbering from here. This will be 6, 5, this will be 1, 2, 3, 4, 5. So it will be 3, 4, 5. So that's a no. Okay, so you always start from this side. So the naming, okay, in terms of the naming, okay, like this, if different halogens are present, okay, so there are 4 halogens just now. Okay, you have fluorine, chlorine, iodine, okay, and bromine. So number all and list them in alphabetical order when writing the name. So this is the last part, which is when you want to write, you write all of the substituents in alphabetical order. So that means here you have 1, 2, 3, 4, 5, 6. So this is at position number 2, bromine position number 3, this methyl group at position number 4. Okay, you don't start from here 1, 2, 3, 4, 5. So it will be 3, 4, 5. So that's a no. So this numbering is correct. But in terms of naming, so you don't write 2 chloro, 3 bromo, 4 methyl. You must arrange according to alphabetical order. So that means it will start with A, B, C. So it's B first. So you have to write 3 bromo, then only 2 chloro, 4 methyl, then this one has 6 carbon, hexane. Okay, if you look at these two, okay, the first example, even though the methyl group are at position number 2 and 4, you have to start with bromine first because this is B, and for this, even though this is dimethyl, but you don't follow the di because the di only denotes the number of methyl. So you take M. So B and M, B comes first in alphabetical order. So 5 bromo, 2, 4. So this, if you have two of the same group, 2, 4 dash dimethyl heptane. Okay, like this one, you have 2, 3 dash dichloro. This is dichloro. Then dash 4, which is this position, dash methyl hexane. Okay, then name them according to alphabetical order. So in this way, if the position of the substituents are at equal length, meaning that if you put here 1, 2, 3, 4, 5, 6, so that means if you start from here or even if you start from here, the numbering will still be the same, 2 and 5. Okay, but you must arrange them or select them based on a alphabetical order. Okay, so it will be 2 bromo. Okay, 2 bromo, 5 methyl, not 5 bromo, 2 methyl. Okay, so this halogen will be prioritized. Okay, that means you will select it to have the lowest number first. Okay, so all of the halogen substituents will be prefixes with the fluoro, chloro, bromo, and iodo. Okay, not fluorine, chlorine, bromine, and iodine. Okay, it ends with O. Fluoro, chloro, bromo, and iodo. Okay, up until that, any questions? Do you have any questions? Clear tak?
No, sir.
Alright, huh?
Clear.
Okay. So, up to the next part, which is the synthesis method. Okay, synthesis meaning how the haloalkane can be obtained. So how do you want to get this haloalkane compound, organic compound? Okay, so you must have a way to synthesize them. So one way is using free radical halogenation reaction. So using this method, what you need is actually the starting material is an alkane, okay, plus with the halogen, for example, chlorine Cl2 or bromine Br2, and the reaction must proceed under UV light, okay, with the presence of UV light. So this symbol is called H nu, okay, UV light. Okay, it looks like a V, but it is not V. We call it nu. Okay, so this symbolizes energy. Okay, that comes from the UV light. If there is no energy present, okay, being supplied or UV light being supplied to the reaction, you will not get the product. No alkyl halide will be formed. Okay, this is very important. Okay, very important. Okay, once you have this, then only you can obtain alkyl halide plus the byproduct. Okay, byproduct. If you are starting material HCl, then it will be HCl. If you are using Br2, then you're gonna get HBr. Okay, so the reaction, this free radical reaction involves 3 steps. One is the first step is called initiation. Second step is called as the propagation, and the last step is the termination. Okay, so this is a mechanism. Mechanism that means step by step of how the product can be formed from the starting material, which is this one. Okay, we look at the first step. The first step is very simple. Okay, just actually one reaction. So it involves the homolytic fission. So homo meaning same. Fission is actually the separation between the bond of this chlorine or bromine. Okay, so this is known as homolytic fission, whereas it will form the chlorine or bromine free radical. So this Cl with a dot over here, okay, they have one dot over here. So this is known as free radical, okay, chlorine free radical. And this step, the initiation step, is the step that will be needing the UV light or the energy. Okay, so if there is no energy being supplied or UV light supplied, then you cannot have the first initiation step. So when you don't have first initiation step, then propagation and termination cannot happen. Okay, so once you have this chlorine free radical, it will go here to the propagation step. Okay, it will be used here, in which that it will react with your alkane. So in this case, we use methane for example. So what it will do is this free radical will form a bond with one of the hydrogen, thus forming this HCl, and your carbon of the carbon from the methane will become carbon free radical. So it will be like this. After that, this carbon free radical, okay, the free radical is a very reactive species. That means when it becomes a free radical, it's very reactive and it is prone to react. So it's not stable, so it prefers to form more stable structures. So once you have this carbon free radical, it will react with some of the chlorine atom that is present. So when you want to do the reaction, okay, you don't just put one molecule of Cl. So there will be thousands of molecules being present in the reaction. So this will be another molecule of chlorine. Hence, you will get your product, this which is the haloalkane, plus another chlorine free radical. So where does this chlorine free radical goes? Is it will go back here to the first step of propagation. Okay, in which that it will be used back here to react with another starting material of alkane. So this step is actually will proceed until all of the alkane is being consumed, meaning finish lah. Okay, so and this step is also known as the chain reaction step, because once you have this free radical, it will keep on continue to react with the alkane. Okay, and the last one, which is the termination step. So this is how the reaction stops basically, is by having the radical free radical to react with each other. Okay, since there are two types of free radical, so you have chlorine free radical bonding with each other to form chlorine again. Okay, and then you have this the carbon free radical and chlorine free radical forming the product that you want, and also the carbon free radical forming another bonding with another carbon free radical to form another alkane, which is in this case an ethane. So here below is the overall reaction. Okay, the overall reaction of free radical reaction. So you must include alkane with halogen and the presence of energy of UV light. So, okay, you can write UV light or you can use this H nu symbol to form the haloalkane. Another way is to prepare haloalkane is using alcohol. Okay, basically the best is to use tertiary alcohol. Okay, by using tertiary alcohol, so what is tertiary? Okay, tertiary meaning that the COH, okay, the carbon that is bonded to the hydroxy group, the OH group, is bonded to 3 other carbon. Okay, basically the same like in tertiary alkyl halide. So you have to react them, which is this tertiary alcohol, with hydrogen halide. So this X can be chlorine, bromine, or iodine to produce alkyl halide. So in terms of reactivity, okay, if you look here, tertiary alkyl halide is tertiary uh, alcohol over here is the most reactive, and then secondary and primary. So this is because of the stability of the free radical. Okay, tertiary carbon free radical is more reactive than secondary and then primary. Primary is the least stable. So example, we have a cyclic alkane. So this is cyclic alkane with OH group. So a cyclic alcohol. So the name here is 1-methyl cyclohexanol. So this is 6 carbon in a cyclic form. So it will not as cyclohexane. But then again, you have OH group over here. So that's why the name become all hexanol. And this methyl group is at position carbon number 1. Okay, 1-methyl cyclohexanol. So it is reacted or mixed with HCl in the form of gas, okay, in the presence of ether. So mainly ether is used as the solvent, and the temperature is done at 0 degrees Celsius. Okay, normally when you done a reaction at low temperature, that means the reaction is exothermic. So it will release heat. So when release heats, there is a probability that it will be there will be some tiny explosion in terms of the reaction, because the reaction will be very reactive. So that's why it is best to keep the temperature low, okay, to control the reaction. So what happen is when you mix with HCl, the OH will get replaced with the halogen group. So HCl become Cl over here, chloro. So now the name will be 1-chloro 1-methyl cyclohexane. Okay, now the name become hexane because there's no more OH over here. Okay, so 1-chloro 1-methyl, because this will be at position number 1. Okay, in a cyclic form, anywhere it starts, so that is considered, anywhere there is a substituents, that will be considered to be as the first carbon. For primary and secondary alcohol, they are less reactive, okay? But then again, you can still react them with thionyl chloride. So which is thionyl chloride? This one, which is SOCl2. Or you can also use phosphorus tribromide, okay, which is PBr3, phosphorus tribromide. Example over here, we have benzoin, which is being converted into decyl chloride. So the OH is being replaced with chlorine, and this one 2-butanol. Okay, this is a secondary. How I know this is secondary? Because this carbon that is bonded to the OH is bonded to 1 carbon, 2 carbon. So secondary, using PBr3 to form 2-bromobutane. Okay, only tertiary will use can be straight away react with HX. Okay, then on to the reaction of alkyl halide. So mainly all of the reaction of alkyl halide is basically known as nucleophilic substitution reaction. Okay, the one that is involved, mainly all of that falls under this type, which is nucleophilic substitution reaction. The first example is known as hydrolysis. Okay, when you heard the word hydro, that means there is water present. Okay, so alkyl halide, okay, it can be converted back to alcohol. Just now, you take alcohol and then you want to change it into alkyl halide, but you can convert it back to alcohol using water or hydroxide as the nucleophile. So what is a nucleophile? Nucleophile is any species, okay, that having high electron density. That means it loves to donate electron. Okay, it loves to donate electron to other carbon or other species. So this is nucleophile. So example over here, we have this CX. Okay, this is general reaction scheme. Okay, you can use either water or hydroxide to form OH. Okay, or RX plus NaOH. So this NaOH correspond to this one, hydroxide, which is you can use sodium hydroxide or potassium hydroxide. Okay, with the presence of ethanol as solvent, and the reaction have to be reflux to obtain the alcohol structures. Or another way is by using water. Okay, this is also the same. So this is a tertiary alkyl halide. You have this C carbon with chlorine attached to 3 other carbon. 1, 2, 3. So tertiary alkyl halide, okay, being reacted or mixed with water in the presence of ethanol. So it form this tertiary alcohol. So ease of hydrolysis, that means which types of alkyl halide is the easiest to hydrolyze. Tertiary will be the easiest to be converted in from alkyl halide to alcohol. Okay, tertiary, secondary, and primary. And then in terms of ease of hydrolysis for alkyl group, the easiest is if you have iodine as the halogen. So iodine, bromine, and chlorine. Okay. Then we have this formation of ether. So the general formula of ether is ROR. So R is, let's say you have alkyl group, and then this is another alkyl group. So the R can be same or it can be different, meaning that example, this one is methyl, this part of R can be ethyl. Okay, so it can be different. So for preparation of unsymmetrical and symmetrical ether, so you can use this alkyl halide to prepare ether. So this is the general reaction pathway in which you have Rx, okay, Rx plus with uh, sodium alkoxide. Okay, this is sodium. Sodium is Na. OR is known as alkoxide. Okay, alkoxide ion. So this sodium alkoxide, then in the presence of ethanol as solvent, then the ether structures will be formed. Example, over here we have bromoethane, CH3CH2Br plus sodium ethoxide. So even though the name alkoxide, alkoxide is general, okay? This depends on the number of carbon. If there is one carbon, CH3ONA, that will be known as sodium methoxide. So in this case, there are two carbons, 1, 2. So it will be known as sodium ethoxide. Okay. So the structures or the final product form will be a symmetrical, okay, symmetrical ether. So this is ethane. This is also ethane. So the compound of this ether will be known as diethyl ether. So the word di stands for there are two ethyl group bonded to this oxygen. So diethyl ether. And then you have this nitrile, formation of nitrile. So it can be formed when you mix alkyl halide and also heated with potassium cyanide in alcohol. So what is potassium cyanide? The formula for potassium cyanide is KCN. K with carbon triple bonded to nitrogen. Okay, triple bond to nitrogen. So the product form will be nitrile, R, C triple bond N. Example, bromoethane. Okay, then you have this potassium cyanide in the presence of alcohol. So this is ethanol. You will get your nitrile over here. CH3, CH2, C triple bond N. And then you can also use the alkyl halide to form an ester. Ester. So formed by heating alkyl halide with silver salt of carboxylic acid in alcohol. So what is silver salt of carboxylic acid? This one. That means the carboxylic acid has been reacted first with silver salt. So now it is known as silver carboxylate salt. Okay. So example, the first one, there are two. So instead of known as what do you call that? Ethanoic acid, this will be known as silver ethanoate. Okay, silver. Ag stands for silver, or the Latin name will be argentum. So that's why the symbol is Ag. Okay, argentum. Okay, this is ethanoate. Then you will get your ester. Example here we have bromomethane mixed with silver ethanoate, and then you will get this new ester structure. And you can also form amines. So amine is any R group that is bonded to NH2 or NHR. Okay, so this is the amine will be covered in the last chapter. Okay, so not to worry. So but just now you should know that amine can be formed by mixing alkyl halide with concentrated nitric acid. concentrated ammonia, okay, ammonia, to form an amine. Example, over here we have bromoethane mixed with concentrated ammonia to form, okay, now an amine, when it becomes a substituent, it will be known as amino. So this will be aminoethane, okay, aminoethane. And the last one, I think this is the last one, is Grignard reagent formation. So this is not an example of nucleophilic substitution reaction. So this is another type of reaction, but then again, alkyl halide is mainly used to form Grignard reagent. So this reagent, it has various uses to synthesize other organic compound. Okay, meaning that it is a useful starting material. But then again, you have to prepare the Grignard reagent using the alkyl halide first. So when primary, secondary, tertiary alkyl or aryl halide react with Mg, stands for magnesium, in the presence of ether, okay, alkyl magnesium halide will be formed. So here you have primary alkyl halide, secondary alkyl halide, tertiary alkyl or aryl. Okay, it can be chlorine, bromine, or iodine, or fluorine. Then you have to mix it with magnesium metal. Okay, magnesium metal, just Mg, in the presence of ether or tetrahydrofuran. So THF is tetrahydrofuran. Okay, so if you mix this Rx with Mg in the presence of either one of the solvent, you're gonna obtain this Grignard reagent. So this is the product here, RMGX. So R can be alkyl, primary alkyl, secondary alkyl, tertiary alkyl, or aryl. MgX can be either one of these halogen. So that is the Grignard reagent. Okay, how it can be formed. Once you obtain this, there are many useful properties to further synthesize other organic compound. Okay, so further reaction with water forms an alkane. Okay, example, once you have this, here you have one bromohexane, 1, 2, 3, 4, 5, 6 carbon, hexane, 1 bromine. This is primary alkyl halide. Why I said primary? Because this carbon is bonded to one other carbon over here, so primary. So it formed this Grignard reagent first, okay, in which that you just add Mg, okay, so CH2, the last one, okay, dash Mg dash Br, okay, bonded to Mg, then this Mg will be bonded to Br. And then if you mix with, if you introduce water to the reaction, okay, then you can obtain your alkane, corresponding alkane, meaning that the MgBr will be removed out. Okay, it will be removed. Okay, the uses of alkyl halide. Okay, what are the functions of alkyl halide? In which form it can be used? One is it is the routes to synthesis other organic compound. So very important in which that you can use it to synthesize other compound. Example, like anti-inflammatory drug, okay, which is ibuprofen. So this can be synthesized by using alkyl halide as starting material, okay, to obtain these structures. Like over here, benzene, the starting material here in the middle, benzene, with other haloalkane, okay. And it can also be used as refrigerants or coolants. So refrigerant is what is in the fridge, okay, your refrigerator. The compressor will pump the refrigerants, so refrigerant will cool the whole fridge. And also coolant is like in your air conditioner, okay, in your car, Normally after several years you have to top up the coolant, okay, so that the aircon can stay cool. And then it is also used in fire extinguishers, okay, fire extinguishers. And lastly, it can also use as pesticide, okay, racun serangga, one of the component lah, okay. Normally in pesticide there is a mixture of other chemicals as well, same like fire extinguisher. So these are some of the main uses of alkyl halide. So that concludes our topic for today. So